Okay, this is the 7.3 assignment that we were assigned before school closure, and we've not had a chance to really talk about it or explain it because we had taken the other assignment that day. Didn't really get to this one. So what I wanted to do is explain this. We had started, I pointed this out a couple days beforehand. I pointed out that when we have two fractions, two rational expressions that we're adding or subtracting together, whenever we combine fractions with addition or subtraction, what do we have to have? Right, common denominator. So we need a common denominator here. So I went ahead and did that. I realized that this side needs x plus 2, top and bottom. This side needs x minus 4, top and bottom. And then we distributed the numerator down here. So 3 times x, 3x. 3 times 2 is your 6. And then remember the negative is going to go with the 2. So negative 2 times x, negative 2x, and negative 2 times negative 4 is our positive 8. We combine our like terms, the 3x and the minus 2 to get x, our 6 and our 8 to get 14, and we have our answer. Or the denominator could be multiplied together. All of that started from this problem here. So, what are we going to do? What we're going to do is we're going to take the answer and we're going to get back to how did the solution start. Those are the partial fractions. So, what we're going to do first is we're going to look at this and we're going to realize, can we factor the denominator? Of course. So, always factor, 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 like we learned way back in Algebra 2. So, we factor this one, and if you recall, x squared, that's nice because that's a 1 there. So, let's see, what are we going to get? We're going to get x plus 14 over, now that's going to be x and x. Let's see. Negative 8, that could be 1 and negative 8, or 2 and negative 4, or negative 2 and positive 4 and negative 8. Let's see. To get to negative 2, I'm going to want to have a negative 4 and a positive 2. That multiplies to give me negative 8, but adds up to be the negative 2. So factor, factor, factor. Anytime you can factor, we're always going to factor. So now from here, we have 4 possible situations when it comes to partial fractions. In this video, I'm going to try to deal with 2 of them. The first one is where we have distinct linear factors in the denominator. It's all about the denominator here for our first decision. All 4 of the other choices. I got the other example here we'll look at in a minute. But we've got a linear, because that's mx plus b, right? A linear form and a constant. And there's a different one there, and there's only one of each. Over here, that's linear, right? That'd be x plus 0 if we wanted to put it in. And this one repeats. That's x minus 3 and x minus 3, because there's 2 of them. So that's a slightly different situation. We'll look at it in a minute. But these are both linear denominator factors. So back over here to this one. Let's see. We know we're trying to break it apart. So it's going to equal some fraction plus some other fraction, right? So what are the denominators of those fractions? Well, in this first case, when we've got distinct linears, well, this one's going to be here, x plus 2, and that one's going to be there, x minus 4. Now notice the plus sign in the middle there. So what's the denominator, or the numerator? That's going to be capital A, and that's different, so it's going to be capital B. So what we're going to do is we're going to figure out, well, what would we need to do to add these together? That's right, we have to have a common denominator. So let's get the other color here. And what are we going to do? This side needs x minus 4. This side needs x plus 2. But better yet, let's just multiply both sides of the equation by the common denominator, and then we get rid of the fraction. Here's what I mean. So over here, let's multiply by x plus 2 and x minus 4. Let's make that look a little better. Plus 2. Over here, let's multiply this whole side by x plus 2 and x minus 4, right? Well, what does that allow us to do? That allows us to actually cross-cancel, right? A little reducing here. So here cancels, here cancel. Well, we just got rid of that fraction. We've got x plus 14 equals. Now over here, what are we going to do? If we multiply this in to here, notice the x plus 2 and the x plus 2 cancel. So what do we got? We've got the x minus 4 times a. Here, well, let's change color here, right? Let's go with orange, just like on the active board, which we'll get back to soon. That thing's on the way. We're getting there. So what happens? The x minus 4 cancels, the x minus 4 cancels, and we're left with the x plus 2 times the b. So let's go ahead and add that in, plus b times x plus 2. Now, from this point, we're going to simplify. And what we're going to do, we're just going to, more distributing, right there and there. So we still have x plus 14. You guys can read that, right? Okay. Equals, I'll try to get a little bigger. A times x minus 4 times a, right? Plus b times x plus 2 times b. Well, now what we want to do, the strategy here, and it's going to be the same in the other 4 cases, the strategy now is to get your x values combined together in descending order. When we get to higher powers, that'll make more sense. So we're going to put the 2 x's to the first power up front. So ax, that's plus, so plus bx. Notice alphabetical order here as well. Minus 4a plus 2b. Okay, well, that's still equal to x plus 14. Now, that's got a common factor of x, doesn't it? Let's factor that out. So if we take the x out, we're left with a plus b times the x. That gives us ax plus bx, right? Well, over here, that's just, let's put this in, plus minus 4a plus 2b. That, like, factor out a 1, a constant, right? Let's do that just to show it. I'll put the 1 right there. So this factored out an x to the first power. This factored out an x to the 0 power, 1, right? So when we get to higher powers, you'll take out an x squared, x to the first, no x, 1. X to the third, or x to the fourth, to the third, the second, the first, the 1. We're not going to go that far up, only up to squares. So anyways, this still equals x plus 14. So now look what we've got. If we draw some lines here, we see that this 1x is the same as the a plus b x. So that tells us that 1 is, let's put it over here, 1 is equal to a plus b. Okay? Well, now let's look at this. Here we've got the negative 4a plus 2b equals the 14. So let's write that. 14 equals negative 4a plus 2b. Make that look like a b. So now you're remembering why we did systems of equations before this, right? We have a system of equations. It's in standard form, so elimination might be the way to do this. Let's see, I would go ahead and multiply this one by a negative 2, perhaps. Actually, let's not do that. Let's just go by the 4, right? So, if we multiply this by 4, and so on, we get 4a plus 4b equals 4. Add them up, that eliminates. We get 6b equals, what's that? 18. So if we divide out the 3, if we divide out the 6, b is 3. We plug that back up here. If b is 3, then A would have to be -2, right? You can do that. So I'm going to say A equals -2. Well, now that we know that, here and here, we can plug it right back here. And we'll have our solution. We'll have -2 over x plus 2 plus 3 over x minus 4. Now, if I recall, we had it in the other order before. Let's see. Was it 3 over x minus 4 minus 2 over x minus 2? Let's take a look. I lost a negative somewhere, didn't I? Plus 2. That was it. You see that right there? Plus 2. So there's your plus and your plus. And look at that. There it is. 3 minus over x minus 4 minus 2 over x plus 2. So there you go. Let's get rid of this guy now. And let's figure out now, how do we do this problem? It's going to be very similar to this one. I'm going to get rid of our answer here because we don't need that anymore. You guys can just back up the video to see it if you want to. We say, what do we do in this case? Well, just like this, we're going to say it's equal to a fraction plus a fraction, but it's going to be for however many different factors we have. So here we have x to the first. So I'm going to put that right there. And then here we've got x minus 3. I'm going to put that right there. But we've also got x minus 3 times x minus 3, the square. So I'm also going to add in plus another one, x minus 3 to the second power. Okay? So we have to get both of those. And one thing you might want to think of is, let's think of this guy as being to the first power. So we've gotten this one to the first and to the second. Now, I'm going to have to squish that way a little bit so we can see this, but we're going to have over top of this our A, B, and C. And we're going to do the same thing that we did here. We're going to go back and we're going to multiply both sides by the common denominator. X times x minus 3 squared. X times x minus 3 squared. Here's going to cancel entirely, leaving us with the x minus 18. Let's separate these guys. Just like in class, right? Here, the x's would cancel, so we would have the a times x minus 3 squared. Now, I'm going to write that here, x minus 3 squared, but I'm going to rewrite it down here, multiplied out, FOILed out, right? Or using my special, I'm going to remember it's x squared minus 6x plus 9. So we would just multiply that on out. Okay. Then here for the b, plus b times, now let's see, only one of those x minus 3's is going to cancel. So the x is still there and another x minus 3 because only one of them canceled. And then over here, both x minus 3's cancel with the c, but the x is left. Bam. Just like that. So let's write this out nice and clean. X minus 18 equals ax squared minus 6ax plus 9a plus bx times x, so we'll say plus bx squared, plus bx times minus 3 bx, and then finally plus cx. Okay, now here's what we're going to do. I'm going to slide over a little bit, give us a little more space there. Okay, combine the largest powers. Remember, we did that over here. We put it in order so the x's were together and then the 1's were together. And I said if we had powers higher, which we do, that's what we're going to get to. So we're going to say x plus 18, well, it's minus, sorry, equals ax squared plus bx squared. And then now let's bring the x's in. So minus 6ax. Where's the other one? There it is. Minus 3bx. And the cx. Now let's see. Did that get everybody? Not quite. Plus 9a. Right? Okay. Well, like we did here, let's factor the x squared out. Okay. Well, over here there's no x squared, so let's think of there as being 1. Let's say there's 0 x squared. We need to think of that now, don't we? Plus 1x minus 18 equals. Now, we're going to take a plus b. We factored the x out. So we're going to realize a plus b is going to equal the 0 in a minute. Here, all 3 of these. So let's color code this a little bit. Here went there. All 3 of these are going to be next. So what are we going to do? We're going to factor just the x out. So we're going to say plus negative 6a minus 3b plus c, all of that times x. Cx minus 3bx minus 6ax. There they all are, right? And then plus 9a. Right, don't forget that one. Right there, came from up there. Okay. Well, there's something I want to show you in a little bit. That's okay, it's a little shortcut. What do we have? We have that the 0 equals a plus b. So a plus b equals 0. We have that the 1 equals this part. So negative 6a minus 3b plus c equals 1. And lastly, let's get some orange in here. The minus 18 is your minus 9a. That's going to be really helpful in a second. Or your plus 9a, sorry. So 9a equals minus 18. So in this problem, we have a nice shortcut that we're pretty happy to get to use. We can realize right here, we can solve for a right off the bat. So we divide by 9. We see that a equals negative 2. Yay. Once we know that a equals negative 2, we can plug that right there. We say a plus b equals 0. So we put the negative 2 in there. And right there, you see, move the 2 on over. B equals positive 2. And lastly, we plug it in right there. We get our last one. So let's go ahead and do this. Negative 6 times a minus 3 times b plus c equals 1. A is negative 2. B is positive 2. So we get 12 minus 6 plus c equals 1. Well, 12 minus 6 is 6. We're happy there. Plus c equals 1. So c would equal negative 5. Well, now that we've got those 4 things there, it's time to write out our answer. Back up to here. A, negative 2, over that denominator, x, plus b, 2, over that denominator, x minus 3, plus c, which is minus 5, which you could put the minus down here, remember, the negative could go there, over that denominator, x minus 3 quantity squared. There would be our partial fraction. Okay? So, the shortcut I wanted to show you was way back over, where was that? It was in a good spot. Here. In this problem here, if you choose good answers for x, you can solve a and b really quickly. So think of it like this way. If x was a 4, that'd be 0, wouldn't it? So 0 times a would make a go away. So what did we put in there? 4. So put it here. 4 plus 2 is 6. We get 6b. And that would be, the 4 also goes here. 4 plus 14 is 18. So we get 18 equals 6b. Divide out the 6. And a equals -2. Then same idea. Put the -2 here. That goes away. Put a -2 there. You get -6a. -2 there becomes 12. Divide both sides by -2. And you get your a equals -2. How did I get that? You can see what I mean, though. Same thing would happen over here. You could put in a value that's going to make, if x were 0, bam, you could solve for a right off the bat. Once you know a, you could then go from there. The problem is it doesn't always work. So in a problem like this one, it works pretty nicely. It gets you right there. Problem like this one's a little bit more complicated, but you can get there. But it doesn't always work. Going the full route works a little easier. The other thing I want to remind you of is you can use your calculator to solve your linear equation here, or you can solve your calculator to find your linear 3D equation here. So if you get 2, 3, 4, 5 variables, just start using your calculator for that. When we get to the testing and quizzing on this part you'll have your calculator for, so you can use your matrices or your RREF to solve them there. So, all good, folks. This was kind of to go back. I hope you get a chance to look at this before we talk on Tuesday, and you can ask me questions during our video conference time. So have a good time. Stay healthy. Be good. Oh, we want our popsicle joke, don't we? Wrong one. Ah, yes. I think you might know this one, though. Let's see. What is a soft drink's favorite kind of music? You're right. Pop! See you later. Bye.